Hello, mathletes, and welcome to today's lesson. Today we're going to be beginning Chapter 9, and we're going to be talking about the Pythagorean Theorem. So we've already done this, so this lesson should be on the fairly easy side and a review for you. All right, here we go. So recall that the Pythagorean theorem, if a triangle ABC is a right triangle, then a squared plus b squared equals c squared. And the two big things that we need to remember in here is that the A and B are the legs of the triangle, and C is always the hypotenuse. And if we're talking about the hypotenuse, that is always the side that is going to be opposite of the right angle. So we have a right angle in here, and the hypotenuse is going to be the side opposite of it, which is going to be the longest side. All right, what is a Pythagorean triple? So remember, the Pythagorean triple is a set of three non-zero whole numbers such that a squared, b squared, and c squared is called the Pythagorean triple. So some different Pythagorean triples that we have are 3, 4, 5, because 3 squared plus 4 squared equals 5 squared. And now if we just double it, we get 6, 8, 10. If you go back to the original and triplet, this would be considered a family of Pythagorean triples. 5, 12, 13 is a Pythagorean triple because they are whole numbers. 5 squared plus 12 squared equals 13 squared. And then underneath here, these are part of all of the same family because they are all multiples of each other. All right, so let's see here. Find the value of x. Okay, so I like to focus on and find my hypotenuse. So 7 squared plus x squared equals 14 squared. So we have 7 squared is 49 and 14 squared is 196. We have 49 plus x squared equals 196. Now if we subtract 49 from both sides, we are going to get x squared equals, so subtract 49, sorry about that, subtract 49, and we get 147. So now we're going to take the square root of both sides, and let's see if there are any perfect squares in 149. So 147 divided by 3. Let's see, so we get square root of 3, square root of 49. So 3 goes in there 49 times, and the square root of 49 is 7. So we have 7 root 3. So x is 7 root 3. Is this a Pythagorean triple? No, because 7 root 3 is not a nice whole number. All right, the converse of the Pythagorean theorem. So if we don't know if this is a right angle, we want to know if this is. Well, if you take the two shorter sides, a squared plus b squared, so the two legs, so these have to be the shorter sides, and if it comes out to be that they equal the longer side squared, then it would have to be a right triangle. Okay? All right, so now, what happens here if we know that we absolutely have a right triangle? And now this is 3, this is 4, this is 5. So we know this is a right triangle. So what happens if we kind of use the hinge and we make this so that this is bigger than 90, and let's just say 92. This is 3, this is 4. Can this side be 5 anymore, or because I just stretched that out, is this going to have to be a little bit bigger? So now we've got 3 squared plus 4 squared, and we're going to get something just a little bit bigger. Let's just say 5.1 squared. And what happened to this angle is this got bigger. So if a squared plus b squared, if c squared is bigger, okay, it got bigger. It's not 5, it's not equal to, but it got bigger here. Then what happened to this angle is that we had to have an obtuse angle here and not a right angle. So our first thing is we're always going to check to see if we do have a right angle. But if what happens if c squared is greater than a squared plus b squared, then we're going to end up with an obtuse triangle. So likewise, what do you think would have happened if I would have made that smaller? So now this is still 3, this is 4, but now let's only make this 88 degrees, so it got smaller. Now, wouldn't that 5 be a little bit long? So in order for this to connect, wouldn't this be shorter? So if c squared is less than a squared plus b squared, then we're going to have an acute triangle. Okay, so what we just went through is if a squared plus b squared equals c squared, then we know we have to have a right triangle. If c squared is bigger, it's an obtuse triangle. If c squared is smaller, it's an acute triangle. Notice that I'm always making my comparison from the right angle. So that's what they're talking about here. If c squared is less, it's acute. If c squared is greater, it's obtuse. And then here, whoops, skipped a screen. Here is the c squared. If it got bigger, c squared is bigger, it's greater than 90, it's obtuse. If c squared is less than 90, it is acute. Alrighty, first of all, we want to make sure that this is a triangle. So 11 plus 18 bigger than 34, 18 plus 34 bigger than 11, and 11 plus 34 is bigger than 18. So yes, this is a triangle. So we always got to check to make sure we have a triangle first. Now, is it right, acute, or obtuse? So we're always going to take the two smaller ones, 11 squared plus 18 squared, and we want to see how that compares to 34 squared. Is it equal? Is c squared bigger? Is c squared less than? Okay, I'm always going to compare it from c squared. So we can just grab your calculator, 11 squared plus 18 squared. I got 445, and 34 squared is 1156. Well, looks to me like c squared is bigger. Okay, so if c squared is bigger, this is going to be an obtuse triangle. All right, let's see. 5 plus 7 is bigger than 10. 7 plus 10 is bigger than 5. Okay, so yes, this is a triangle. So 5 squared plus 7 squared, how does that compare to 10 squared? So what do we have? 25 plus 49 is 100. So 25 plus 49 is 74. Okay, so, and this is 100. So c squared is bigger than a squared plus b squared. So this is going to be obtuse. Okay, c squared is bigger than the other two combined. So we do have an obtuse triangle. All right, that's weird that they were both obtuse. So did I do my math wrong here? 11 squared plus 18 squared is 445, and 34 squared is 1156. So c squared is bigger. So because c squared is bigger, this one is obtuse. So they were both obtuse. Alrighty, well, it is homework time. So good luck on your homework in lesson 9-1.